In a stunning announcement that has sent ripples through the software development world, Google has unveiled its latest foray into the AI-powered programming space with Vibe Coding AI, a revolutionary system that transcends traditional code completion and generation by operating on a fundamentally different principle: visual interactive behavioral execution. Unlike previous coding assistants that primarily function as sophisticated autocomplete systems, predicting the next line or block of code based on statistical patterns in training data, Vibe represents a paradigm shift by enabling developers to create software through a combination of natural language instruction, visual manipulation of program elements, and real-time interaction with a living, breathing prototype of the application being built. The system's core innovation lies in its ability to understand and execute intent-based programming, where a developer can describe a desired feature or behavior in plain English, or even demonstrate it through a rough sketch or interactive mock-up. And Vibe will not only generate the corresponding code, but will instantiate a fully functional, interactive version of that feature within the development environment, allowing for immediate testing, iteration, and refinement before a single line of human-written code is ever committed. This is made possible by a groundbreaking architecture that combines a massive language model specifically trained on paired code behavior datasets with a sophisticated visual reasoning engine and a dynamic execution sandbox, creating a feedback loop where the AI can visually comprehend what the developer is trying to build, generate the code to achieve it, and then demonstrate the resulting behavior for verification, all in a matter of seconds. The practical implications of this technology are nothing short of transformative for the software development lifecycle. Imagine a front-end developer working on a new user interface who can simply draw a rough wireframe of a login form with their finger on a tablet, and Vibe instantly generates the corresponding HTML, CSS, and JavaScript, complete with proper form validation and accessibility attributes, while simultaneously rendering a live, interactive version that responds to clicks and inputs. Or consider a back-end engineer describing a complex API endpoint in natural language. Create a RESTful endpoint that accepts a user ID, validates it against the database, retrieves their order history from the last 30 days, calculates the total spend, and returns it as JSON with appropriate error handling for invalid IDs or database connection issues. Instead of spending an hour writing, testing, and debugging the root, controller, and service logic, Vibe generates the complete, production-ready code across all necessary layers, including the database query, input validation, error handling, and serialization, in multiple languages like Python, Java, or Go, complete with unit tests and API documentation. The system's behavioral debugging feature is perhaps its most powerful aspect. When a developer encounters a bug, they can simply demonstrate the erroneous behavior by interacting with the running application, and Vibe will not only identify the root cause in the codebase, but will suggest and implement specific fixes, explaining the logic behind its correction in a way that educates the developer rather than just mechanically patching the problem. What truly sets Vibe apart from predecessors like GitHub Copilot or Amazon Code Whisperer is its deep integration with Google's ecosystem and its full-stack coherence capability. The AI maintains a holistic understanding of an entire application, from the user interface down to the database schema and infrastructure configuration. When a developer requests a new feature, Vibe doesn't just generate code for one layer. It understands the architectural implications across the entire stack. Requesting Add User Authentication with Google OAuth would result in Vibe generating the front-end login button, the OAuth configuration, the back-end authentication controller, the necessary database migrations to store user sessions, and even the cloud configuration for secure key management in Google Cloud Platform, all while ensuring that the new feature integrates seamlessly with the existing codebase's patterns and security standards. This contextual awareness extends to legacy systems as well. Vibe can analyze millions of lines of existing corporate code, understand the established architectural patterns and business logic, and generate new features that maintain consistency with the legacy system's style and constraints. something that has been a perpetual challenge for AI coding tools until now. The underlying technological breakthroughs that enable Vibe's capabilities are multifaceted. Its training involved a novel dataset comprising not just code repositories, but synchronized code behavior pairs, recordings of applications being built and then used, allowing the model to learn the causal relationship between programming decisions and their runtime consequences. The system employs a differentiable code interpreter that can execute code symbolically during the generation process, enabling it to reason about program behavior before finalizing its output. Its visual reasoning module was trained on a massive corpus of UI designs, screenshots, and their corresponding implementation code, allowing it to translate visual concepts into functional interfaces. Perhaps most impressively, Vibe incorporates a collaboration memory that learns from the specific preferences, patterns, and past decisions of the development teams using it, continuously refining its suggestions to align with the team's established coding standards, architectural principles, and even naming conventions, effectively becoming a personalized coding partner rather than a generic assistant. The impact on developer productivity and software quality is already demonstrating dramatic results in early access programs. Teams report reducing development time for new features by 60–80%, with particularly significant gains in prototyping, debugging, and test creation. Junior developers are able to contribute production-quality code much faster, while senior engineers can offload routine implementation tasks to focus on architectural design and complex problem-solving. The system has shown remarkable proficiency in generating comprehensive test suites, security-hardened code, and accessibility-compliant interfaces, areas that often require specialized expertise. However, Vibe is not without its controversies and challenges. Concerns about code originality, security vulnerabilities in AI-generated code, and the potential for accelerating the creation of malicious software are being hotly debated. Google has implemented several safeguards, including provenance tracking that identifies which parts of a codebase were AI-generated, automated security scanning of all generated code, and usage policies that prohibit certain applications. But the ethical dimensions of such powerful technology remain complex. As Vibe begins rolling out to developers through Google's Cloud Code platform and popular IDEs, it's clear that this isn't just another incremental improvement in developer tools, but a fundamental reimagining of the programming process itself. By bridging the gap between intention and implementation through visual interaction and behavioral demonstration, Vibe has the potential to democratize software creation, accelerate innovation, and fundamentally change the role of the software developer from someone who primarily writes code to someone who primarily designs, specifies, and verifies system behavior. While it won't replace human developers in the foreseeable future, it will undoubtedly transform their workflow, making software development more accessible, more efficient, and potentially more creative by removing the friction between idea and execution. In the highly competitive landscape of AI-assisted development, Google has not just entered the race. With Vibe coding AI, they have potentially lapped the field, establishing a new benchmark for what's possible when artificial intelligence truly understands not just how to write code, but how software actually works in practice.